couple of notes I want to add on page 2. So get your pen or pencil out and write these notes on page 12. The first note has to do with the fact that if the voltage at the voltage divider circuit is less than 0.7. So, you don't have to draw this. This is already shown on page 1 of your notes 12. That's my voltage divider circuit, R1, R2, and at the division is where we connect the transistor. Okay, this voltage we'll call VB because it's the voltage at the base, and when we refer to a voltage with a single letter of the alphabet, it is always with respect to ground. So VB is base to ground. VC on the other side here, voltage at the collector again is to ground. So it's from here all the way to here. Okay? If in the lab you are asked to measure VC, you would measure it from the collector to ground. Single letter of the alphabet is always with respect to ground. So VB is the voltage at the base, which also happens to be VR2, right? VR2 is the voltage across R2. Is that also the voltage VB? So I want you to write this note at the bottom of page 2, note 5. Are there 4 notes at the bottom of page 2? Add note 5. Note 5 says, if VB is less than 0.7, if VB, the voltage at the base, is less than 0.7, the transistor will not turn on if VB is less than 0.7, the transistor does not turn on. We've said that it takes current in the base to turn the transistor on, right? If current starts flowing into the transistor, current starts flowing into the collector. Now we're saying that that current in the base also will flow if there's a voltage there, right? There's no current if there's no voltage. And the voltage is VB. And that voltage has to be more than 0.7 to turn the transistor on. What are we talking about? What 0.7 are we talking about? Is it the voltage from the base to the emitter? Okay. VBE, how much have we measured that in our lab?
To 0.7.
About 0.7, isn't it? So that voltage at B has to be higher than 0.7 in order for the transistor to turn on. In other words, it has to be 1, 2, 3, 4, 5, depending on the value of VCC, of course. But if VB is 0.2 or 0.3, then that transistor will not turn on, okay, if it's less than 0.7. Therefore, if I was to measure VCE, the transistor will act like an open, not turning on, means that the transistor will act like an open switch. Okay? And what's the voltage from the collector to the emitter if it acts like an open switch? VCC, the supply voltage. And what about the current, IC? The current in the transistor, if it's open, can any current flow through an open switch? No. So the current is zero. So this is one note I wanted you to add at the bottom of page 2 in case VB is less than 0.7. And in our lab this week, that's what we're going to find out with a circuit I'm building in the lab. The second note is to do with IB. So what I want you to do is there's a bullet IB, and it says it's equal to VB over HFE times RE. Can you cross this out like this? Cross out that equation, okay? And write down this equation maybe on the side. There's some space on the side. Write down IB is VB over R in base. Pardon? Yes, IB equals, so I want you to write this note on the other side of IB in the space that you have on the right. This equation is available in the textbook, and so I wanted to correct the information that's there. R in base happens to be the resistance that we see at the base of the transistor, and so let's define, and we can say where R in base is equal to beta times VB over IE. Okay, this is an equation that's given in the textbook, so we're going to fix it here in our notes. And that was the last thing that I had to calculate on page 4. I did the example on page 3, the voltage divider circuit, and in that voltage divider circuit, what I wanted to do was find the load line and the Q point. With any biasing circuit, the objective is to find the Q point. Okay? And we found it. So let's tell me what my Q point was for the example on page 3. What was my VCE cutoff? How much? 5? 5, wasn't 5 the Q point? 5 volts. So what was the cutoff point here? 10. What was my saturation for the current? Was it 22 or 2.2?